our focus will be examining primary energy usage at home. As these fuels are non-renewable, we need to find a more efficient way of using this limited resource. This pie chart shows the breakdown of energy consumption at home. We can see that energy consumed by lighting takes up a significant 10%. This is why our team has decided to focus on it. Non-renewable energy is defined as energy that takes a long time to be replenished. The following are examples of non-renewable energy. Fossil fuels refer to resources such as coal, petroleum, and natural gas formed by the decomposition of dead organisms millions of years ago. Nuclear energy refers to energy released during nuclear fusion or fission. Renewable energy is defined as energy that is continuously replenished. The following are examples of renewable energy. Hydropower energy refers to energy generated by the flow of water. Wind energy refers to energy generated by the flow of air. Solar energy refers to energy derived from sunlight. Through our research, we came across the skylight. A skylight is a window set in a roof. This increases the amount of natural light in a room significantly. We did a case study on Bras Basah MRT station, which also uses skylights. Our site analysis proved useful as it allowed us to examine how the skylight affected the intensity of light passing through it. A unique feature of the skylight at Bras Basah MRT station is the flow of water through it. After all our research, we discovered one limitation in the current skylight design. It could only illuminate a small part of the room, which was determined by the position of the sun. Our goal in prototype 1 was to overcome this limitation. We discovered one limitation in the current skylight design. It could only illuminate a small part of the room, which was determined by the position of the sun. Our site analysis proved useful as it allowed us to examine how the skylight affected the intensity of light passing through it. On further analysis, however, we realized that the reflected light was insufficient. Furthermore, the reflective panels took up too much space. As such, we scrapped the idea and went back to the drawing boards. After much consideration, we realized that the root of the problem lies with the roof. In order to allow sunlight into the room throughout the day, we designed a hexagonal-shaped roof with skylights on each side of the roof. No matter the position of the sun, sunlight will always shine into the room. However, on further analysis, we realized that this idea produced a new problem. By increasing the exposure of sunlight in the room, we are also increasing the amount of radiation the room receives, which will heat up the room. In Singapore's already hot climate, this means that we will end up spending more energy on cooling appliances. We realize that our challenge now is to provide natural lighting while maintaining the coolness of the room. In order to do this, we decided to explore the cooling properties of water. Our third prototype revolved around the idea of using water to absorb the radiation from the sun. Water is inserted between the layers of glass panels in our skylight. The water absorbs radiation from the sun and as a result, keeps the room cool. This heated water can be used for other purposes such as bathing. Overall, we will be saving electricity on both lighting and water heating. Our experiments showed that the presence of water had negligible effects on light intensity in the room, while the room temperature remained constant. As such, this idea proved feasible. Our challenge for the next prototype is to implement the water circulation system. For this to work, we decided to make use of convection currents in water to circulate it. Once water in the panels are heated to the optimal temperature, a temperature sensor detects this and a valve is opened at the top to drain the water out. The reason why the valve is placed at the top is because heated water has a lower density and will rise. This water is then channeled to a storage container. The storage container has its own electrical water heater as a backup, as there may be times when we do not experience sufficient sunlight to heat the water. The hot water in the storage container can be channeled to the bathroom by other pipes. the cold water in the storage container will sink and be channeled into the skylight water heater by another pipe to be heated up. Overall, the whole system will ensure a continual flow of water and ensure that the water will always be heated. Based on our calculations, the energy saved by this system will take a total of 5 years to outweigh the cost of the system. Besides the roof on houses, our skylight water heater can be installed on the roofs of car parks, balconies, porches,